Hi everyone, in this video I'm going to discuss budget constraints. And really there's two things to discuss here. The first thing is the construction of the curve algebraically, and the second is the interpretation of our slope and intercepts once we draw the curve. Now, a budget constraint will typically look like this diagram to the right here. It's downward sloping, and the whole point of this line is that it tracks the various bundles of two different goods that we can exactly afford given our income and the price of each good. So the bundles that completely exhaust my income. In my diagram here, my horizontal axis variable is going to track the amount of good 1 that I have in my bundle. So x1 is equal to good 1. And x2, I've got that on my vertical axis, and that's going to track the amount of good 2 that I have in my bundle. P1 will stand for the price of good 1, and P2 will stand for the price of good 2. Lastly, the letter M can stand for our income. Now, the algebraic construction is actually really intuitive, and we can start by thinking, well, the total amount of money that we spend on our consumption bundle, so the value of our consumption bundle, cannot exceed or has to be less than or equal to the amount of income that we have. Now, this amounts to, well, the total amount that we spend on good 1, which is going to be x1, which is how much of good 1 we consume, multiplied by its price P1, plus the whole amount that we spend on good 2, which is going to be how much of good 2 that we purchase, multiplied by its price. Well, the sum of these spendings on good 1 and good 2 has to be less than or equal to our income. So this inequality here is what we call the budget set, and this set tells us all of the possible or feasible consumption bundles that we can afford. Visually, we see this as the area under and including the line of our budget constraint, just like this. Now, as I said previously, the budget line itself tracks those bundles that cost exactly M. And so we're going to write the equality here, and that's our budget line or our budget constraint. Now, what I want to do with the equation of this budget line is work with it until the variable x2 is isolated on the left-hand side. The reason why I do this is because if you recall back to when you learnt about drawing the equation of the line, is that if we have two axes and typically it's x and y, the standard form of the equation of the line is something like y is equal to ax plus c, where our coefficient on x is the slope, and c, which is our constant, is the y-axis intercept. So sometimes c is b, and sometimes a is m. I've already used m for income, so I replaced it with a, so I hope all of this isn't confusing for you. The point is that when we have y isolated on the left-hand side, the coefficient on x is the slope, and the constant is the vertical axis intercept. Now, the analog of this form, in the case of the budget constraint, is to put x2 on the left-hand side, because x2 is the vertical axis variable, just like y. So to do that, just working with our budget constraint or our budget line equation, we can start by taking away x1, p1 from both sides, and we get, well, x2, p2 is equal to m minus x1 times p1. And then we simply divide both sides by p2, and we get, well, the p2's cancel out here, so we have x2 is equal to m divided by p2 minus x1 times p1 divided by p2. Now I'm going to clean this up to x2 is equal to m divided by p2 minus p1 over p2 times x1, which is an equivalent way of expressing the line before. And so now we're in exactly the same form as I had up here. We can see that negative p1 over p2 is the coefficient on our horizontal axis variable, which is x1. So as I expected, our slope comes back as negative, it's downward sloping. And the constant here is m divided by p2, which will be our vertical axis intercept. So in terms of interpretation, let's start by interpreting our intercepts. And let's first think about that vertical axis intercept, which we have, which is m divided by p2. Now the budget line, recall, is the amount of goods that we can buy if we exhaust all of our income. Now right at the point of the x2 intercept, the amount of x1 or good one that we buy is equal to 0. So essentially, this point represents the amount of good 2 that I can buy if I spend all of my income on good 2. Well, this is exactly right. Since m is our income and p2 is the price of good 2, if we divide our income by the price of good 2, we get exactly the amount of good 2 that we can buy if we spend all of our income on good 2. And our x1 axis intercept, or our horizontal axis intercept, can be found and interpreted in a similar or the same way. So at this intercept, the amount of good 2 that we're consuming is equal to 0. So this point will be the maximum amount of good 1 that I can buy with my income if I spend all of my income on good 1. And we can find that just by taking our income and divide that by the price of good 1. Now it's worth just quickly seeing this algebraically from our equation of the budget line. So let's set x2 equal to 0 in our budget line equation. If we do that, we would get, well, 0 is equal to m divided by p2 minus p1 over p2 times x1. So I've just subbed in 0 for x2. Now in order to solve for x1, we can add p1 over p2 times x1 to both sides, and we'll get p1 over p2 times x1 is equal to m divided by p2. We can then multiply both sides by p2 and we can cancel out those denominators. And we're left with p1 times x1 is equal to m. Now divide both sides by p1 and we get x1 is equal to m divided by p1. So we get that expected value m over p1 for that intercept value. And actually it's worth just thinking about a quick demonstration. If the price of good 1 was 10 and the price of good 2 was 5, and if my income was 20, then if I spend all of my income on good 1, well, I could at most buy 20 divided by 10, that's m divided by p1. I could at most buy 2 of good 1, and that's our horizontal axis intercept. If I spent all my money on good 2, I could buy, well, my income is 20, each good 2 costs $5, 20 divided by 5 is 4, and that's my vertical axis intercept. So this is actually a neat and alternative shortcut to drawing budget constraints. Just divide your income by P2 to get the vertical axis intercept, and divide your income by P1 to get your horizontal axis intercept. And so lastly, let's just turn our attention to the slope here of the budget constraint, which, as we found before, is the negative of the ratio of prices, so negative P1 over P2. And I'm going to interpret this as how much of good 2 we have to give up because we buy one more of good 1. To say this in another way, it's the rate at which we can trade good 1 for good 2 in the marketplace. And we can use our example here again to illustrate. So the price of good 1 was $10, right? And the price of good 2 was $5. Well, once we substitute these prices in, we can see the slope would be, well, negative 10 over 5 is negative 2. Well, the interpretation of this is that if I buy one more of good 1, I spend $10 on that good, I'm going to have to give up 2 units of good 2. And that's completely consistent with our prices being 10 and 5. And so that's what we mean when we say that the slope is the rate at which we can trade good 1 for good 2 in the marketplace. So this discussion is quite abstract. In another video, I'm going to go through an applied example, which will hopefully make this discussion more concrete. So I'll link to that in the description once it's done. So I hope the video did help you with understanding budget constraints. If it did, please like and subscribe. I hope you guys are having a lovely day or night.